So this I can put in 10.125. Okay? Now, where is p increasing? All right, so I'm going to highlight the increasing section. Okay? So increasing, going up. Where is this graph going up? So it starts low, and it goes up. And then where else is it going up? From 4.5, or not, from 3 on. Okay? So increasing is negative infinity to negative 1.5. Union, remember we put a u, 3 to infinity. Okay? Decreasing is everywhere else. So this negative 1.5 to 3. And we're done, right? Little bit of a longer problem. Okay? All right. So how do we find the local extreme of a polynomial? What did we do? We find the midpoint of the roots. Plug in to find the y value. Okay. Polynomials are symmetric, so that's why it's like that. Polynomials are symmetric. Okay, next thing we're going to talk about is multiplicity. This squared means multiplicity. Technically, remember, you can write this as x plus 6, x minus 3, x minus 3. Multiplicity means this is actually a double root. It technically hits this twice, right? So multiplicity is a point on the graph where there is more than one root at one point. So anytime you have x minus 3 squared, x plus 5 to the 5th, those are all multiplicities. Okay? All right. So we've got 3 practice problems. So let's do the next one. All right. So start by finding the zeros. What are our zeros? So we have x equals, well, we have a plain x, so that's 0. X equals 2, and x equals 8. Okay, so I just switch the sign. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, and 2. Now, 1, oh, and 0. Just kidding, 0. Now, what is the degree of this polynomial? How many x's do we have? We have 1, 2, 3, 4, 5, 6. So it's an x to the 6th problem. There's no negatives in the front, so it's a plain x to the 6th. All right. So what direction are the ends going to go in? The positive direction. So they're both going up. Okay. Now, the tricky part here is at x, is there a duplicity at 0? No. So this is going to come down. Now, x to the 3rd, what's an x to the 3rd look like? Think about what an x to the 3rd looks like. X to the 3rd is the one that does this little weird thing around there. So that's actually what's going to happen on this problem. At 2, we're going to kind of do a little thing, like a little weird shape there. Okay? So it does a kind of weird well, it's not a duplicity. It's a triplicity? I don't know what that word is. So a multiplicity is 3, though. So we want it to do that little like x cubed weirdness. All right? And then what's happening x to the 8 at x minus 8? At 8, we also have a duplicity, right? It's an x squared. It's like a little parabola. So it's going to look like that. So that's what our graph looks like. Little weirder, right? Little weirder. So what's our local extrema, though? Right? So what's halfway between? This is 0 and 2. What's halfway between? 1. And then now this isn't actually an extreme point. It's just that weird, it's actually called a concavity point. It's just a little weird spot that makes a little move. Okay? So what are the other ones then? Well, we have 8, right? because that's a parabola, so 8, 0. That's easy. And then what is halfway between these two roots? What's halfway between 2 and 8? Well, that's 6. What's halfway between 6? Equals 3. So we're 3 away from the roots. So what is that? 5. Okay. But now we need to figure out the y values. So to figure out the y values, we're going to plug in. Again, I'm going to break out my calculator. So I'm going to plug in 1 first. So I have 1 times 1. Can you see? 1 times 1 minus 2. Wow, it would help if I to the third times 1 minus 8 to the second. Let's see what we get. Negative 49. So this point down here